Okay. Special factoring for trinomial squares. It has to have a positive here. If it is a square, this will be the sign of what's in there. Okay? And I think the only way to really explain what this 2AB means is to start factoring them and see what it means. Like, if we were to factor this just normal without realizing it's a square, we would put x and x. This is actually a square. It's 5 times 5, right? Does 5 double to give you 10? Yes. Okay, 5 and 5. How are we going to get a negative 10?
Minus
By
5 plus, 2.
Negative, negative. See, they're both the same. This ends up being x minus 5 squared. If you can go straight to here, that's fine. If not, separate it out and realize it's a square. Okay. This one, do they have anything in common? No. Are they in descending order? No. We need to put it in descending order. 16y squared plus 56y plus 49. Now it's in descending order. They didn't have anything in common, no common factor to factor out. Is this a square and is this a square?
Yes.
Great, that's what we want.
4 and 4, 7 and 7.
Okay. 7 and 7. Okay, to get the y squared, we also need
1.
y and y. So it's 4y, 4y, and it ends in 7, 7. We have a 56 here. How are we going to get 56 out of that?
Multiply those.
28 and 28. That adds up to 56, right?
Yes.
So that's good. How are we going to get a positive? They have to both be that side. So we have 4y plus 7 squared. Okay. We can do it either way. We put the y squares first, or the x squares first, but they do need to be in some descending order. Whether you want the x's first, it don't matter. Let's put the x squared term first, just so they'll be in alphabetical. You could do it the other way too, though. Okay, x squared, so we need the x term next. The term that has an x by itself, so, or, single x. So minus 20xy. Then the last term will be your y squared term. So it's in descending in x's and ascending in y's. Is there anything in common? Common factor? No. Okay. So is this a square and a square?
Yes.
Great. 25x?
5 and 5. And 2 and 4. 1 and 2 and 2.
We need the 5 and the x, right?
And
We
then
need 2 what?
2y.
2y. How are we going to get negative 20? We've got a 10 and a 10.
Both negatives.
Right. We write that as 5x minus 2y squared. Okay. Next term, is it in descending order? Of the x's, yeah. And ascending with y's. Does it have anything in common? 2. Okay, let's factor 2 out first. Next term.
6xy.
6xy, last term,
9y squared.
okay. Are these both perfect squares?
Yes.
One is a square too, yes. X square, y square. So we have x and x. What are we going to have for the 9y square? 3y?
3y.
How are we going to get negative 6? Both negative. So we'll rewrite it with this being a square. Okay, do we have the next one in descending order of, all we have is y's. No. Biggest one is this, right? So let's go negative 144, y to the 8th, minus 4y, oops, plus 45, sorry. That's the next biggest one, and then minus. Do we like having a negative out here? No. First term should be positive. Let's do the negative 1. We have 144, y to the 8th, and we'll change the sign. And change the sign. Is 144 and 4 squares? Is this, if it's even, you can divide it in half, so it is. So we have the negative 1 up here. 144 is 12. Half of that to the 4th, right, y to the 4th. And 4y squared?
2y.
2y. Now we're going to get negative 45.
Both negative.
Doesn't work.
That's weird. I wonder if I wrote the number wrong. 24 and 24.
348, not 45.
The only way it's going to work is if it's 48, huh?
Yeah, just,
Think I wrote it wrong?
yep.
Probably. If it's going to work. So if it's going to work, we'll have to change that to 48, huh? Sorry, guys. I was doing it right before class, and I got distracted. I've been distracted all day, sorry. So 24 and 24. How are we going to get negative 48?
Both negative.
Right. So we got negative 1 times 12y to the 4th minus 2y
Squared.
squared. I'm sure I wrote it out of the book, but don't know if I didn't have my finger there or if I just didn't read it right. Okay, another special factoring thing is difference of squares. Always has to have the minus here. If it has a plus and it's both squares, it's not going to factor. So if you have the problem a squared plus 36, that will be prime. You cannot factor that. Okay? It has to have the minus and be perfect squares to fit this. This won't factor no matter what you're doing. Okay, so if it has perfect squares and a minus, it will factor to be the square root of that, which is x, and the square root of that, which is
Plus
3.
3 minus 3.
Plus and minus, right. You should have done a lot of this in 114. Okay, we didn't have anything in common up there. Do we have anything in common here? 5. So that'd be 1.
X squared. Y 6.
Okay. Is that a perfect square? 1 times 1. That's x times x. That's y3, y3. So yes, difference of squares. 1 is 1 times 1. I'm going to put the y part first, so it fits on there. 1 is our exponents. The x would be 1, right? 1, 1's 2.
Y would be 3.
3, right.
Both
Signs? Huh?
Minus.
Both minus?
No, it would be plus minus.
Plus and minus. So there's your answer. Okay, do these have anything in common?
True.
Let's get that out of there then. They're just the 2. So we'll have x to the 4th minus what?
4,
To the 4th.
4y to the 4th.
Are these perfect squares?
Yes.
Difference of squares, okay. X to the 4th is what?
Squared.
Squared, squared. This is what?
2 and 2.
2y squared.
Yeah. And 2y squared plus and minus.
Plus and minus. Everybody seeing this?
Does it matter if I put a minus first?
No, it doesn't matter. I like to do this, the plus first and then the minus, because sometimes this one keeps factoring, and that way you can just carry the plus parts down, and you can keep factoring the minus ones, because if it keeps turning into a difference of squares, you don't want it to be like in the middle of the problem. So I like to put the plus first, because it's just more convenient. Okay. What do they have anything in common?
16.
16, will 16 go into 121?
No.
No? I don't think they have anything in common. Those are both squares, right? What about the x's?
They're all squared.
X squared in both of them, doesn't it?
Yeah.
And they don't both have a y, so that's all they have in common. Joey, what do we put here?
X.
X to the 6th. X to the 3rd.
Keep trying.
X to the 17th.
Keep trying.
X to the 4th.
2 and 4 give you 6. And then, what do we put here? We don't need x squared.
Just X.
Why?
It's already X squared.
Why?
Why was it?
To the 4th. We don't have any y's out here, so we're going to put them all there, right? Okay. Perfect square? Perfect square?
Yes.
We got difference of perfect squares then. This is out here. 16x to the 4th is what times itself?
4.
X squared.
What did you say? For what?
4x to the 2nd power.
To the 2nd, right. And then this one? I'm going to put the
11
y part first so I have room for it.
to the 2nd power.
2nd,
And it's 11.
and that's 11. And the sides?
Plus and minus.
Right.
Forgot your square.
You can't rewrite that any simpler because they're different sides, you can't write it as a square.
Forgot your x square on your first.
Oh. Yeah, we can't change this front number either. Okay, does that have anything in common here? Nope. Both squares, this 36 is a square. Okay. Z is z times z, z squared is z times z. How are we going to get 1/36?
6. 1 over 6.
1 over 6. 1/6 times 1/6. 1 times 1 is 1, 6 times
Plus and
6 is
minus.
36. And a plus and a minus. There you go. And I don't know why I left so much blank room on that page. I don't know why I turned this one upside down. Okay. I don't know. I don't know why I do a lot of things. Okay. Factor by grouping, we've already been doing that. but we'll do a few more. What do these have in common?
X squared.
Okay, first term,
X.
second
Three.
term. So we write this again. -4. -4x and -12. That works. What do they have in common? X plus 3. This part,
X squared minus 4.
are we done factoring?
No.
We gotta keep factoring, we have a difference of squares. Bring this one down, and this one keeps factoring.
X, 2, and 2.
X and X, 2 and 2,
Plus and minus.
plus and minus. Everybody seeing that? Okay. Don't see anything in common. Going down, that's okay. Let's group it. What do these two have in common?
X,
So the first term,
X,
plus 6. That's not gonna work. Okay? Sometimes when you're grouping, it's not always 2 and 2. Okay? So if it doesn't work to do that, what you're gonna have to do is start over and maybe group these separately. Okay, that might factor. So, we're gonna start over because that didn't work. Does that factor? X and X minus 3 and 3, that adds up to 6. So this is plus a plus, right? And I'm gonna bring my minus y squared down. This is squared. We have a difference of perfect squares. Okay, so if we, what is this squared? It's x plus 3 squared. Square root of it, right? It's this times itself. The last term, y times y. What are the sides?
plus and
Plus and
minus.
minus. You haven't seen one of those, huh? You haven't seen them as often. Okay. After, what do they have in common? Nothing. So when you, even if we tried to group them, they wouldn't have anything in common, would they? What if we do these?
Well, the last 3.
The last 3? See if the first 3
Well,
will
25 is a perfect square.
Yeah, but this one had a perfect square at the end too, and we just left it.
Oh, okay.
So if we could get this into a perfect square minus a perfect square, that'll be good. X and y. Is it gonna add up to 2? 1 and 1,
Yeah.
yeah? So we have x minus y squared, and then minus 25. That is the difference of squares. So, we have 25 is 5 and 5. This squared is x minus y times itself,
Plus and minus.
plus and minus. You're going to do the same thing to this one. Because these have C in common, but you're going to end up with like C plus 4. That's never going to turn into that. Okay, so factor this, should be a perfect square. C and C, that'd be 2 and 2. And Philip, what would we put for signs?
Plus and minus.
No.
Oh, same signs.
Stand up. Help you. Stand up. This squared minus this squared. Difference of squares. So I'm going to start with the end. 9 is 3 times 3. This is C plus 2D. And then our signs.
Plus and minus.
Plus and minus. Stand up. Everybody finished with that? Okay, probably same thing again, right? That's not a perfect square. Okay, is there anything in common first? 3. 4x squared.
4x plus 1 minus 1y squared.
Okay. There's our minus a square, so let's see if we can do this. Okay, a perfect square, perfect square. Got 2x
2x
and 2x. 1 and 1. 2x and 2x add up to 4x when you're positives, right?
Yes.
So we put minus y squared. Okay,
2x
that's
plus 1 squared.
squared minus the squared. Okay. Y, right? And this,
2x plus 1. And then plus and minus.
plus and minus. Okay? Alrighty then. I think this is the last thing. See that SOP over there? That's what this refers to. Same, opposite, positive.
What was the, formula for the one before that?
The what?
The AB plus,
A squared plus A squared,
for the one that we're in,
the difference of squares, it was A squared minus B squared equals A plus B, A minus B.
not that.
The square root of that. That was it. We were still doing, oh, grouping? There's no,
perfect squares.
you just have to decide what to group.
And what happens to them?
Okay, I got them out of order
Now
now.
you gotta put the sum of
The so.
There we go.
difference of cubes.
Okay, there we go. Cubes. So you have the sum of cubes, you're going to have a positive, the same thing that you had here, you're going to have here. That's what the S stands for, the same. So your first one here, where they're both all by themselves, well, the same sign. Then you have this, the A part will be square, different sign, the opposite sign of this. This times this, and then plus, because it'll be positive, the second one squared. So it's the same thing, you put the A and B with the same sign, this squared. If you want to go ahead and put this B squared at the end, you can. This squared, that squared. The middle term will be the opposite side of this and multiply these two numbers. The AB means you multiply those two numbers. Takes a little to get used to.
Where's this?
Hmm?
Where's the SOP again?
Same, opposite,
different?
positive. Same sign, opposite side, and positive. The last one's always positive here. I guess you could think of it as stop, maybe, without a T. I don't know. You could say same times, same times, the opposite positive in there. I don't know. However you can remember SOP. It would be cool if it was SOS, but it's not. It's not same, opposite, same. Same, opposite, positive. I guess you could think of a pig, you're stopping the pig. Okay. Okay, so let's do this. Let's use this. We're going to have one with 2 terms, and then we're going to have one with 3 terms. First 2 terms will be, see how you do the cube of that, cube root of it, cube root of that will be x. If you want to put the x in the x squared, you could, because it's always going to be that and the squared right there. Okay. And 27, that's why you have a sheet with cubes. What's a cube?
3.
Yeah, the cube root of 27 is 3. Okay. Cube root of it goes there. And then this squared goes at the end. 3 times 9. So these two have to multiply to give you that. 3 times 9 give you 27. Okay. What's the signs again? Same, opposite, and positive. We have one more thing we need. We need that middle term. We get the middle term by multiplying this times this.
Be 3x.
Right. 3 times x. Okay,
So when you, to check your answer.
you can multiply that. You could do this times all 3 of them, and this times all 3 of them, and a lot of it's going to cancel except for the first and last terms. Okay? Q to the third will be q times q squared, right? S to the third will be s times s squared. This and then square it. And what's our signs going to be?
Minus,
Same,
plus,
opposite,
plus.
positive. Now, what's our middle term going to be? QS, or SQ, or whatever, however you, I put QS because the Q's coming in down in descending order there.
Oh, wouldn't it be QS anyway? The Q comes before F?
Right. Well, we put 3x, but that's just the normal way to write that. Okay, more of these. Perfect cube, look at your sheet.
Yes, 5.
Yes, perfect, perfect. Okay, so we're going to use the plus one. Okay, this cubed is 5. What is 5 squared? 5 times 5, 25. That multiplies to give you 125. See that? And you need the x. And it also has to be squared. Okay, the y cubed, you need the y, and it needs to be squared. Our signs,
Plus,
same,
opposite,
opposite,
positive.
positive. Our middle term,
5xy.
right, 5xy. Perfect square? Yes?
Now we get cube.
I mean cubed, I'm sorry, not square. Perfect cube, yes. Perfect cube,
3.
yes. And 1, right? 1 times 1 times 1 is 1. Okay, so we got 2 here and 3 here. 27 cubed is
3.
3. Squared is 3 squared, 9. X cubed is x. When you square that, you have,
Squared.
right? 1 cube is 1. When you, 1 times 1,
1.
1. Now our signs,
Plus,
same,
positive, or negative,
opposite,
positive.
positive.
4x.
Multiply,
4x,
Oh.
multiply,
3x.
Yes.
okay, is 8 a cube?
Mm-hmm.
2, okay. 2 and square that,
4.
8
And then a cubed.
cubed,
I mean squared, sorry.
squared, okay. 1 and 1, right?
Yeah.
1 squared is 1. Sides,
Plus, minus,
same, opposite,
and plus.
positive. Middle term,
2a.
2a times 1 is 2a. Okay, perfect cubes. 2. 2's not a perfect cube, is it?
Neither one of them are.
Do we have something in common? 2. Let's factor that 2 out. That's the only thing we have in common. Okay. Perfect cube?
Yes.
Perfect cube? Yes, okay. 2 and 3. Y cubed is y and y squared. And 27, 3. And 3 squared? 9. The z part? Z and
Z squared.
z squared. Signs? Same,
Opposite.
opposite, positive. Same, opposite, positive. Middle term?
3yz.
Right, multiply. Okay. Perfect cubes? Yes, but don't we have a common factor? Would something go into both of those
Yeah,
numbers?
8.
Yeah, let's factor the 8 out. We'll have 8 x to the 6th minus,
To the t.
that's a t, sorry about that. Perfect cubes? Yes. Okay. 2 and 3. 8 is what? 2 cubed, right? 2 to 2 is 2. 2 times 2 is 4. So that's the cube root of it. That's 2 squared. How about the x to the 6th? Divide it by 3 and you'll have a cube root of that.
2.
2. If you square that, you double it. So there's 4. See those add up to 6? So divide that by 3 for the first one. Okay? Okay, t to the 6th divided by 3 is squared, right? Double that. Okay. Signs? Same. Opposite. Positive. Our little term.
No, 2 t squared x squared.
Or 2.
Yeah, 2x squared t squared. I'm just putting the x first because we started with the x here. I think we're almost done.
Wait, what was that last term?
Okay.
Never mind,
Alrighty. Have anything in common?
3.
3? Oh, it's our last paper. And anything else?
Z squared.
Yeah. Because we're looking and seeing this isn't cubed, so we probably better find something to make it right. So the first thing will be z cubed minus what? 1. So we'll do this on the outside. 2 and 3. Cube root of z squared, z cubed is z and square it here. Cube root of 1, 1, and square it here. What's the signs? Same? Opposite?
Positive.
Positive. What's our middle term?
1z.
1 times z. We just need to put z. We don't have to put the 1. And one more. Do we have anything in common? Nothing, no common factors. Okay. Is this a perfect cube? Does that divide by 3?
Yes.
Cube? Yes. Divides by 3. So 2 and 3. Divide this by 3 to get your exponent.
3.
3. Square that so you're doubling that exponent.
6.
See, they add up to 9. That's good. Okay. We're going to do the same with the b before we put the number here because we want to have room for our b there. Okay, so the b, we're going to divide it by 3 and double it, right. Now, about the 64.
8
Cube root of 64.
would be all the cube.
4?
4.
4 times 4, you're going to square it.
16.
Okay, put 4 and 16. Signs?
Same.
Same.
Minus.
Opposite.
Opposite. Positive. Middle term.
4a cubed b cubed.
4a cubed, b cubed. Putting them in alphabetical order. Any questions? No? No questions?